that has to be this length, that is z square, plus this length square. No? Oh, this is right angle, right? I'm sorry, this is right angle. Ah, circular piston. And I have a z, and I'm measuring sound over here. So this is a right angle. I'm sorry, that's why you're confused. Okay, I have a circular disc over here. Now I am measuring sound at the center of the circular disc, therefore, right angle, and this is R, so R square has to be this one plus this one. That makes sense, okay. So, this is the equation we have to integrate. That is simple. Let what makes this integration difficult? This is more. This bothers us very much, right? When something bothers us very much in mathematics, what we usually do, replace that bothering things with something that does not bother us, right? So let that one is alpha square and zeta square plus z square, then 2 alpha, the alpha is equal to, for the fixed z, arbitrary z, okay, that is 2 zeta, the zeta, and therefore I can write that this is jk rho 0 c over 2 pi, and the integration come from when zeta equal 0, this come from z2, when z goes to a, that should go a square plus z square square root, and I have here I have alpha, and I have exponential jk alpha, and then I have what? 2, then okay, I have 2 pi, cancel out. I have alpha, the alpha, and this go away. Now, beautifully, we have the integral that is pretty easy to get the result. And that is not well precisely written in the text, because I assume that the reader who will read my book has good mathematical background so that they can always derive it. But I certainly, when today I found that it is too much. I overestimated too much the reader's mathematics. So the result, very simple, has a very simple form that says, that is simply minus rho 0 c un jka over 2a over z exponential jkz. Wow, that is interesting. The result says simply that the sound radiating from the baffled piston observed at the center line, that is the z-axis, Does it look like what? Exponential jk z over z type, that means monopole. Monopole. What I observed at the center line, due to the radiating baffled piston, just to look like monopole. Okay? Okay. So let me summarize what we learned today. So we reviewed the sound radiation due to breathing sphere and the traveling sphere, and we found that radiated power has interesting characteristic like 6 dB per octave or 12 dB per octave type characteristic. That's the typical difference between the traveling sphere and the breathing sphere. And then we start to understand the sound radiation due to baffled piston is because we want to know more general case. Okay. Maybe we will argue later on the sound field generated by baffled piston is somewhat similar superposition of breathing sphere and the traveling sphere. That's maybe we will get that kind of result, we will be very happy, right? Oh, any sound field can be approximately achieved by using traveling sphere and breathing sphere, but we didn't finish all the derivation. In the meantime, we learned the way to apply Kirchhoff-Helmholtz integral equation to specific case, and we now understood that it is not trivial. We need some exercise to apply the Kirchhoff-Helmholtz integral equation for the vibrating sound radiation from vibrating surfaces. And we practiced, and we got the Rayleigh integral equation from the Kirchhoff-Helmholtz integral equation, and we applied that Rayleigh integral equation to the baffled equation. We obtained the solution that looked like this, and we did not go into detailed physical interpretation of what we got today, but that will be extended in the next lecture. And tonight you will see the very heavy homework that will give you some power or ability to apply Kirchhoff-Helmholtz integral equation in general case, right? That's what you have to learn. You have to know as a graduate student. If you are undergraduate student, demonstration is enough. And understanding far field concept and near field concept is enough. Understand the 6 dB per octave and 12 dB per octave concept is enough. But graduate student has to know at least a little bit more than what undergraduate student can do. So I want you to understand very well about Kirchhoff-Helmholtz integral equation. That will be given to you as a homework tonight. Okay?